steel structural detailing by using AutoLISP program in ZWCAD. Hi my dear friends, I am very glad to meet you through this seminar. Now we are going to see how to perform steel structural detailing by using AutoLISP program in ZWCAD. Let's go step by step. Creating plate. Now we are going to create a plate by using the command ZA. Now I follow the prompt, enter plate or grating insertion point. I pick here as an insertion point and enter plate or grating horizontal length. I enter the horizontal length as 200 and enter plate or grating vertical length. I enter the vertical length as 300. Then it asks enter normal plate thick. So now I enter the plate thickness as 6 mm thick. Now a plate has been created with 6 mm thick and width of this plate is 200 and length of this plate is 300. Now I mark the part name, that is 6 thick plate, and part number 1. Now let us check this dimension. The vertical dimension is 300 and the horizontal dimension is 200. So let us check. The width of the plate is 200 and length of the plate is 300. In other method of creating plate, that is if the plate is in polyline or in rectangle, so we can create by using the existing polyline. Now I create a rectangle. The rectangle is also a type of polyline. So now I enter the command AZ, then I select this rectangle and it asks the thickness of plate, say for example 12. So now the plate with 12 thick has been created and the width of the plate is 196.49 and the length of the plate is 241.8. Now I mark the part name and part number. Now let us check the dimension. Vertical dimension is 242 and horizontal dimensions is 196. Let us check. See, width of the plate is 196 and the length of the plate is 241.8. Say 242. That's all. If the plate is an irregular shape, for example, I draw a plate as polyline. This is an irregular shape. Now we can create plate by using the existing command AZ. As usual, I select this plate and I enter the thickness of this plate, for example 16. Now the plate has been created with 16 thick. The width of the plate is 206.9 and the length of the plate is 259.27. Now I mark the part name and part number. Okay, let us check the dimension. That is overall plate finishing dimension. That means width of the plate is 206.9. Say 207. So width of the plate is 207 and the length of the plate is 259. 259. That's all. Creating checkered plate and grating. We have created this plate as normal plate. Now we are going to create checkered plate. I enter the command ptp, that means plate type. So here enter type. So number 1 is normal type, number 2 is checkered plate, number 3 means grating. So now I choose number 2, that means checkered plate option has been selected. Now I create a checkered plate, as it is already we have created a plate. That is, I create a plate by using the command ZA. Now I enter the insertion point and the horizontal length is, say for example 100, and the vertical length is for example 200, and the thickness of checkered plate is 6. So here the checkered plate with the 6 mm thick has been created, and its width is 100 and the length of the checkered plate is 200. Now I mark the part name and part number. Okay, let's check the dimension. See, the width of the checkered plate is 100 and the length of the checkered plate is 200. As well as we can create grating by selecting the option number 3, that is PTP option number 3. Now I have created a plate that means grating by using a rectangle. Now I run the command AZ, then I select this rectangle and I have entered the grating thickness, for example 25. Now the grating with the 25 thick has been created and its width is 226. The length of this grating is 268. Let us check. So here we mark the part name, that is 25 thick grating, and the part number as 5. Now let us check the dimension. See, the width of the grating is 226.7, means 227, and the length of the grating is 268.5, means 269. That's all. Creating steel profiles. Now we are going to see how to create steel profiles. Now I create the L angle, for example say L 100 by 100 by 10, and I follow the prompt. I pick the start point and end point. The name of this profile is ISA 100 by 100 by 10. The part number is 6. Now again I run this program. For example L 100 by or 110 by 10. Here is the start point and end point. We can provide the length for this end point, for example 250. That's all. So the name of this profile is ISA 110 by 110 by 10 and the part number is 7. The dimension, let us check the dimension. 250. Now I am going to create channel ISMC. Say for example 200 CF means 200 channel flange facing. I pick the start point and end point. Name of this profile is ISMC 200 and part number 8. Now I create 200 channel web facing. This is a start point, this is the end point. The name of this profile is ISMC 200 and part number 9. Now I have create beam, that is ISMB. Say for example 100 BF means beam with flange facing. So this is ISMB 100 with flange facing and part number 10. Now I create the beam, that is ISMB 100 with web facing. I pick the start point and end point, for example with the length of 300. That's all. This is the web facing ISMB 100 part number 11. Let us check the dimension. Dimension already we provide 300. That's all. Creating gusset plate. This is a miscellaneous process. So here a brace is there. So here we can create gusset plate by using the command WS. Now I follow the prompt, that is pick brace outer line. I pick the brace outer line here. Then I follow the prompt, pick first point on the edge of the primary part. So this is the primary part. I pick the first point on the primary part and last point on the primary part. I pick here. Then gusset plate direction point. I need the gusset plate direction in this direction. So I pick here. Then pick first edge point on brace. So this is the first edge point on brace and last edge point on brace. This is the last edge point on the brace. Then pick plate vertex first point. This is the first point on plate vertex and second point. Then this is the third point. This is the fourth point and fifth point. Now I enter the thickness as for example 6 thick plate. Now the plate has been created with 6 mm thick. So I mark the plate name, that is 6 thick plate and part number. Now let us check the dimension. So the width of the plate is 194.3, 194, say 194. Then length of the plate is 205.7, that is 206. 205.7 means 206. Let us create in another edge. So I run the command WS. Then I follow the prompt. I pick the brace outer line. I pick the first point on the primary part and last point on the primary part. Direction of gusset, first edge point on brace, last edge point on brace, plate vertex first point, second point, third point, fourth point, and fifth point. The thickness, for example 12, the plate has been created with 12 mm thick. The plate name is 12 thick plate and part number 13. Let us check the dimension. See, the width of the plate is 199.7 means 200, and length of the plate is 200.2 means 200. That's all. Now we are going to create a simple steel structural plan. Creating single part. We can create single part by using the command A222. After entering the command A222, now I follow the prompt. The single parts has been created successfully. Let us check the single part. This is part number 1, ISMB 100, part number 2, ISMC 200, part number 3, ISA 130 130 ton, part number 4, ISMC 200, part number 5, 12 thick plate, part number 6, 6 mm thick plate, part number 7, 8 thick plate, and part number 8, 10 thick plate. That's all. Creating BOM, that is bill of material. We can create bill of material by using the command table. Now I have export these profiles and plates block data to CSV file format. After some editing work in Excel, we can bring bill of material into the drawing as Excel format. That's all. Thanks for watching.